Hello everyone, my name is Akira Youngblood. I've been at Shining Mountain since kindergarten. For my senior project, I conceptualized, built, and designed a controller for real-time performance called the Lumozel. The core concept is using optical sensing to determine the position of the hands and using the resulting information to generate music. Tonight, I will show you how the Lumozel was developed and how it works. When I first began to think of my senior project, I was completely at a loss. I had no clue what I was going to do, and a deadline was fast approaching for my proposal, and things were looking grim. So I wanted something that tied together some of my diverse interests, and I knew I wanted to build something tangible, and that was really about as much as I knew. Eventually, I had an idea. I would build a musical controller. I had these basic ideas for it. I thought it could be played with the hands, it would use non-contact sensing, it would communicate with a computer that would allow for more controllability, and I wanted it to be sort of easy to play for someone who maybe didn't really know a whole lot about music and be easy to improvise on. So I set about designing it. The basic principle I used was infrared range finding. Infrared range finding is a technique where you can take a beam of infrared light, so infrared is below red, so it's not visible, but it's still light, and you can bounce it off something. So you have a little beam of light here, bounces off your hand, comes back over here. Based on this angle over here, you can determine how far away this is. So I thought, okay, I can use my hand and I can range find off the hand. So that became the underlying sensing concept of the Lumozel. The basic structure is have sensors such as the infrared rangefinders. They communicate with an Arduino. I'll get to what an Arduino is later. The Arduino relays data back to the computer, and then custom software that I wrote takes that data and interprets it and generates MIDI, and the MIDI is sent to internal or external instruments. A little bit on MIDI will come later. So the flowchart operation for the software, just the basic actions, the software will check it looks at all the sensor values. It checks to see if a laser has been broken. The laser is there to know whether or not there's a hand present. If the laser's broken, that's assumed to be a hand present. It looks at the distance, and based on the distance, it figures out what note to play. And then it updates the screen and keeps on going and around and around and around. So a little bit on the software. It was built in processing. I wrote it and it works, and I'm happy. I've written quite a number of different revisions of the same software. So this is one revision. The version I'll use tonight will be a little bit different. A little bit on MIDI. Again, this is what the computer then sends out from the software I wrote will send out MIDI to other things. MIDI is Musical Instrument Digital Interface. It's a protocol, simple protocol. The easiest way to explain it is instead of sending audio to another device or something, it instead sends a little instruction. It essentially says, play a note. It doesn't tell you what the note sounds like. It just says, play a note. So by using MIDI, I can have the software connect to things like synthesizers, external synthesizers, even internal synthesizers. So for instance, many of you may be familiar with GarageBand. I can play instruments in GarageBand. Next, I started to build the thing after I had this concept. The first thing I did was researching all the existing controllers. There's a fair amount of stuff out there that uses non-contact sensing, and I looked at all of it. And every interface and controller I saw had a problem with it, something that I didn't like, limitations. So I came up with a concept that would get around these limitations. Next, I looked for mentors. I found two mentors. Whit Goodrich, who's an electrical engineer. He helped me immensely with all the circuitry and buying strange parts that I wasn't quite sure what they did. Helped a lot. And Andrew McGill, who's a software developer. He helped me a lot with figuring out some of the software aspects and also working on a lot of what the interface was going to be like and how it would be presented to the user. So back to an Arduino. This is the brains of the project. It takes the sensor data and sends it off to the computer. What is an Arduino? An Arduino is a microcontroller. What's a microcontroller? A microcontroller is a little computer. I have an Arduino right here. They're quite small. This one's name is actually dumber because I fried it and it doesn't really work as well anymore. But essentially, it's a little computer and it helps things go between raw sensor data and the rest of the computer. So I chose an Arduino for several reasons. One, it's open source, so there's a lot of people who've done nice things with it, and it's easy to see, oh, that person's done that, I could possibly do something similar. It's affordable. A lot of microcontrollers are kind of expensive. It's pretty popular, and another thing that was really nice is it's easy to program. What I mean by that is a lot of microcontrollers out there are programmed with assembly language, which looks a little bit like this. And that's not the greatest to learn. It's lots of numbers and little abbreviations. Arduino language looks a bit like this, which is much easier to understand. For sensing hands, I used a couple of things. The sharp infrared rangefinders are what determine the distance to the hand. Then there's a laser set up on one end of the chassis and a phototransistor set up on the other end. And what that does is the laser, I'm sure you're all familiar with a laser, it sends a beam of light down, and the phototransistor is sort of like a little eye. It just says, well, is there a laser there or is there not? And it tells that to the Arduino. So that allows me to determine if there is a hand there or not. Now, I put together a prototype once I had all the parts. It was really basic. I just used a simple single ranger and an Arduino. And testing the prototype, I ran into a very large problem. Jitter. The data coming back from the Ranger had lots of problems. This shows an oscilloscope trace of the data, and essentially so it's showing you the amplitude of the signal is on the horizontal axis, and the y-axis is time. Sorry, the x-axis is time. Those intervals are about 0.5 milliseconds. So you can see this is a very high frequency component. That should be a straight line because it's showing a constant distance, but it wasn't. So that meant that the computer thought that the distance was constantly changing a couple thousand times a second, very drastically, which really isn't helpful when you're trying to figure out where a hand is. So I talked to my mentors, I tried to figure out what I could do, and eventually we came up with some solutions that we thought would really improve the situation. We added a new power supply that was a little bit beefier and also isolated it from the rest of the circuit. And we added capacitors to buffer out this current draw. Capacitors are sort of like shock absorbers. They sit there, and when a jolt comes in, they kind of smooth it out. So with all these modifications in mind, after the prototype, I wrote up the final schematic and began building the Lumozel. The final build just began with blueprints. I drew out all the pieces I wanted, the wood and all that, and started putting everything together. I built the power supplies, I soldered everything, put together the main board, and then began testing it because I didn't want to put a component in and have it suddenly smoke. That all went well. And then I had a final instrument. So now I'm going to show you the instrument. It looks a little bit different than that. Just mention the software that I'm going to be using looks like this. It allows me to control a couple things, octave, key, scale, and all that. So now I'm going to So this is the Lumozel. You can see there's components along here. There's a rangefinder here and here. If you can see, there's a little window right here, and most of the circuitry is there. I'm going to plug it into the computer. It needs a little bit of time to wake up, as it were. So there's lasers here. The phototransistors are over here, matched with the lasers. And then I'm going to start the software. The other thing is that by using a fairly simple design, it's completely modular, so in theory someone who wanted to could easily expand this design to multiple beams. So now I can adjust the scale. I'll set this to both beams to C pentatonic, because I like pentatonic. It's hard to mess up in pentatonic. Hand. It's nice, isn't it? So along this axis controls pitch, and there's two beams, and they are completely independent of each other. So if I here, it's a pretty low note, whereas there, and I can do things like that. And then there's also things, for instance, you can actually assign different beams to different instruments, which then is really nice because you can actually play two different instruments. So maybe you could think of it on a piano as maybe you want to play left hand and right hand. Well, this you can actually play, the left hand of the piano would actually not be a piano, it would be something entirely different. So you have something like that, and then again we have this sound over here. And then I can also switch back to a piano on this one. It's interesting, by using the laser I can do very quick things, so because it senses individual fingers quite quickly. But you notice it has troubles with consistency because the rangefinder is actually not really seeing my hand as well because my fingers are spread. So that's the Lumozel. So just a little bit, it's not over yet. This is by no means the end of this project. I have future plans for it. Some of them may happen. There's some things that I'd really like to add to it. Also, all of the code that I wrote for the project is available publicly on GitHub. I'm hoping that, some of the stuff may come in handy sometime. This project would most definitely not have been possible without a great number of people. Huge thanks to my parents for continual support and great ideas and aesthetic criticisms when necessary, which was probably often. Thanks to Greg Fisher for letting me use his shop. I built most of the Lumozel in his shop, and it was a huge help. Thanks to Joseph Johnston for help with music theory and designing a usable interface. And then thanks to Marty for helping with the speech, and Dave and Joan for getting this whole thing together and keeping the senior projects great. And lastly, my mentors, Andrew McGill and Whit Goodrich, if you guys could stand up. Thanks. Thank you. That concludes my project. Questions? Stephen.
Bob, where does the name come from?
Question was, where does the name come from? I chose the name, not really when I began the project, but a little bit later on. The Lumo is from light, because it uses light. The Zel was really just a syllable that was added on, because I wanted a unique name. Yeah, Andrew. Question was, can you slide your hand across, or do you have to break the beam for different notes? Yeah. Yeah. So creating a sort of a portamento effect. With this current software, which is by no means done, breaking the beam triggers the beginning of the note, and the frequency is, the pitch of the note is fixed from that point on. However, with just a very small software modification, it could easily do a lot of sort of pitch bends and stuff. Yeah. Yeah. Question was, is this the only Lumozel in the whole wide world? Yes, it is. This is, to the best of my knowledge, this is the only one of its kind. Yeah. Question was, can we hear it again? Sure, briefly.
Can you play a song?
I don't have a whole lot of practice, I must admit, as this has only been in a currently existing state for a couple days or a week or so. So, not really. Sorry. Yeah, so as Andrew was asking, when you put your hand in the beam, it does sort of set the pitch for the rest of the note. So it doesn't change, but then it'll pick it up again. So, yeah. Any others?